Hey guys, welcome to another video for chemistry. This video I'm going to be working out a couple problems from your chapter assessment. I'm looking at electrons and atoms. More specifically, I'm looking at electron configuration, orbital notation. So we're looking at some of these problems. I'm starting out with number 87 here. And number 87 wants to see what element is represented by each electron configuration. So I'm looking at A through F. We'll see how far I get. I may or may not do all of them. We'll see. So let's look at the first one. Electron configuration 1s2, 2s2, 2p5. So just as a reminder, this is my S block here, right? Here's my D block. Here's my P block. And then here's my F block down below. And recall that helium is a part of the S block, right? So just a quick little reminder of that. So as I'm going through this, so I have 1s2, so that takes me all the way through here. And then 2s2 takes me through my second period. And the fact that I have 2 electrons tells me that I go all the way through. And then I go jump all the way through. I jump to 2p5. So that's, and this electron here, that number 5, is very key because that tells me, this electron, this superscript, tells me how many steps or how many times I go forward, or how many electrons I have. So that would be 1, 2, hold on, this is not thick enough, 2, 3, 4, and then 5. This is where I would stop right here at that point. Okay, so that tells me that's the identifying component to what I'm looking at. That's element, that's fluorine. So this is fluorine right there. Okay, so let's work out another one. So let's see here. Now I'm looking at argon. So this right here is noble gas notation. So I immediately go to argon. So here's argon. This is my starting point. And then I go to 4s2. So argon, and then this is period 1, period 2, period 3, and period 4. So argon, and then period 4, 4s. Okay, now the question is, how many electrons do I have? I have 2. So that means I have calcium is my element. That's the element that I'm looking for, calcium. So letter B is calcium. All right. So next is xenon. Okay. So I'm gonna go locate xenon, and here it is, xenon on my periodic table. There is xenon. And now what I want to do next is look at what else it has. So 6s2, so 5, 6, that's 6s2, that takes me all the way through this s orbital, and I go into 4f. And recall that this space right here, this space is where my f orbitals go, all this period right there. Okay, so that's my 4f, all of this top row is my 4f. So I'm looking at one of the elements in that row, and how do I find which element? Well, I just carefully look at how many electrons I'm working with, and that's 4 electrons on the F row. So that's 1, 2, 3, and here it is, 4, neodymium. That is my magic element. That's the one I'm looking for. So Nd, neodymium. Okay, so let's continue. I actually want to leave these up just for just for maybe making it just a bit easier sake here. So I'm looking at Krypton. So this is my starting point because it's noble gas notation, right? Looking at Krypton. And I know that I go through 5s2 and 4d10. So 5s2, right? And then 4d10, I go all the way through 4d10. And then I'm at 5p4. So this is the row, my 5p row. Yeah, let me do it in green. My 5p row, let me thicken it up, 5p, and there's 4 electrons, so 1, 2, 3, and here it is, tellurium. That's my magic element there, tellurium. Alright, so that is tellurium. Okay, so hopefully that was helpful enough for you to get through number 87. So um, let's jump over to 88. Let's work out 2 from 88, just so you can see how it works. Looking at 88, it's saying which electron configuration notation describes an excited state. Okay, an excited state. So recall that in excited state, the electron started at a grounded state. Okay, it started at a grounded state and then it got excited, so that means I have an electron that jumped. It jumped from one floor to the next, if you will. So something that you're going to be looking for is you're going to be looking for an electron that is out of place. It's out of place and it's hanging out in a state and a level that is above its normal place. Okay? So again, I'm looking for an electron that is above its normal place. So let's look at A. Let's start off with A. So we have argon, and you'll notice that I go from argon to 4s2. Okay, that's pretty standard because I look at my periodic table. See, let me zoom in a little bit. See, here's argon, right? There's argon, and I have 4s2, which is expected, right? I have 4s2, and then I have 3d10, which is also expected, nothing out of place there. And then I go to 4p2, so 1, 2. Okay, so there's nothing really out of place there. The electrons seem to be okay. And let's go to the next one. I have now neon. I have neon. Where's neon? Right there. Neon in blue. And then I have 3s2. Nothing out of place there. And then 3p5 ending there. That seems to be okay. And then, okay, let's go to the next one. I'm not finding anything abnormal. Remember, I'm looking for things that are out of place. So I go to Krypton, and then Krypton I have 5s2, and then I have 4d1. That seems to be okay too. Let's go to the next one. Okay, one of these has to be out of place, right? So the next one is D. So I start off at argon, and then I go to 4s2, pretty standard there. And then I go to 3d8. So that's 1, 2, 3, 4, 5, 6, 7, and then 8. Now the problem is that I should still have 2 more electrons, right? Because the Ds contain a maximum of 10, yet one of the electrons is out of place. One of these electrons seem to have jumped from the d orbital into my 4p orbital. So it jumped out of place. So hopefully you recognize that and you saw that. So one of my d electrons, which belongs over here, jumped into a level above it without actually filling out the whole d orbital first, right? So it violated Pauli's exclusion principle, or actually Aufbau's principle, where you're supposed to fill in the lower levels first before you go to the higher levels. So it violated that. So this electron here didn't necessarily violate it. All it meant is that it was in an excited state. It had an energy. So eventually that electron it will come back to its original state. Okay? All right, so hopefully that made some sense. We'll do 91. So an atom of arsenic has how many electron containing orbitals? Okay, so how many orbitals? How many orbitals are completely filled? How many orbitals are associated with N4 principal energy level? And we're looking at arsenic, right? So the first thing we got to do is we have to find arsenic. So let's go ahead and let's fill out its electron configuration so we can see what it looks like. So arsenic is going to be 1s2, 2s2, 2p6, right? 2p6, and then 3s2, and then 3p6, and then 4s2, right? 4s2, and then I have 3d10. After 3d10, 4p6, p3. All right, so that's my electron configuration for arsenic. Let's go back to the questions. It says, an atom of arsenic has how many electron-containing orbitals? How many orbitals? Well, let's go ahead and count them out. So we have 1, 2, and then there's 3 here. So that's 1, 2, 5, 6, 9, 10, and then this is 5, 14, and then 14, and so that's going to have, this is going to be 17. 17 electron-containing orbitals. Okay, 17. So let me make sure that's right. So we have 1, 2, 5, 6, 9, 10. Oh, that's 15. 18, actually 18. All right, so I'm glad I double checked. That's 18. So 18 electron-containing orbitals, right? Remember that there's 10 electrons, so there's 5. And let me write this one out so you can see that there's actually 3. So remember there's 3 orbitals for the p, right? They're all dumbbell shaped, and I have 3 electrons, so that's 1 electron, that's 2, and then that's 3. So that means I have 3 orbitals that are filled. That's what pushes me up to 18. Okay? So what's the next portion of this? It says, how many orbitals are completely filled? Okay, and I kind of just, so I did the last one. The last one that let me draw it out again. The last one had 3 filled orbitals, but the rest of them were completely filled. So if I only had 3 half-filled orbitals, that means the rest of them were complete. So that means the next part is I had 15 full orbitals. Now, how many orbitals, the last part, how many orbitals are associated with N4? Okay, how many orbitals? So this fourth energy level, so what I'm doing is that I'm looking for all the orbitals that had principal energy level number 4. So I'm going to highlight them. Here's 1, principal energy number 4, and then here's another one, and that's the only 2. So now the question is how many orbitals are associated with those 2? And I already said with this one here I have 3 orbitals. 1, 2, and then 3. And then with the 4s, you know that the s is only a single orbital, right? So that's 3, that's 4. So I have 4 orbitals that are associated with principal energy level number 4. Okay? All right, that does it for that. Okay, guys, I'm going to stop this video at this point. I hope that me working out these problems was helpful. If not, remember that you can always come in for tutoring. So good luck in your studying.